All right, today in class we continue to look at proportional relationships and equations. And we've started to get into graphing equations that have proportional relationship. And one of the ways we accomplished this was using a t-chart or an xy chart, as you see on the page here. And I told you that we could pick any random set of values for any of our x's, plug those x values into the equation, and whatever our input for x values is multiplied by our rate or our constant would result in a outputted y value. And I generally like to stick with numbers that are easy for me to graph, so I will do something like a -1, 0, 1, and 2. Now, since we know that all of these graphs are proportional, I could have just as easily done -2, -1, 1, 2. Because any proportional graph is going to go through the origin of our coordinate plane. But since I've used the values -1, 0, 1, and 2, I'm first going to plug each of these x values in to find out what my output becomes when I input a -1 for my x value. So 3 times -1 would equal -3. 3 times 0, well, that's going to be 0. 3 times 1, that's easy, that's 3. 3 times 2, that would output 6. So my t-chart would look something like this. A point at -1, -3, a point at 0, 0, which is the origin, a point at 1, 3, and a point at 2, 6. So now, in order for me to give you the best view of what's being graphed, you're not going to be able to see the graph and the t-chart in the same screen. But you should have all these numbers written down on your own paper by now and can reference just the graph. So the graph I gave you doesn't have any numbers on it because I wanted you to be able to use whatever numbers you came up with and whatever hash marks you needed to do. So first I would graph -1, -3. So I move to the left 1 and down 3. And that's going to be my first point on this graph. My second point, it's at the origin, 0, 0. My third point, up to the right 1, up 3. My fourth point, to the right 2, up 6. And now that I have 4 points, I can simply connect the dots, preferably using a straight edge, so that the rest of my line looks somewhat accurate with how it should look. But we would end up with a line that looks something like this. You were also asked to fill out a table that looked something like the one provided. Well, this is the one provided, in which you were asked to identify all of the missing components. Our first table gives us the equation y equals 3/4 x, and we know that we're utilizing the equation y equals kx, so my value 3/4 is equivalent to k. So my constant equals 3/4. Zoom in just a little bit. All right, and then I'm going to fill out a table. And I don't need a whole lot of points. Like we said in class, you only need 2 points for a line. Since I want to verify that it goes through the origin, I'm going to go ahead and use the 0 for one of my terms. And just as we discussed in class, if I find a multiple of my denominator, that will allow my outputted y value to be a whole number. So I'm going to input a -4 and input a +4. So when I plug -4 in for x, I get 3/4 times -4 which outputs a -3. When I plug a 0 in for x, 0 times 3/4 is 0. And when I plug a 4 in for x, it outputs a +3. Which should have been the most obvious because we know that our k is equal to y over x. And so we should have a 3 for a y with a 4 for an x. And now again, just as we did the previous problem, you should be able to graph, given any of those set of points, a graph that represents what you will see on the key. Hopefully this gets you pretty well prepared for where we will continue to go in class.